I'm Ryan. I'm a science teacher.
I'm Cheryl, and I slept through science.
Each episode will tackle a science question you may have learned in school, but can't quite remember or fully explain.
And I'll take the risk of asking the dumb questions so that we can all understand the science we slept through.
The bell has rung. Let's get started. Welcome to Lesson 17. We are in our hot and cold unit. Cheryl, what are you curious about today?
Well, Ryan, ever since we started this podcast, so many lessons ago at this point, I think almost every lesson we have come up with some sort of question that we're like, add it to the list, add it to the list, add it to, and our list is getting long, Ryan. I hate to break it to you.
Getting really long.
We have a lot of science questions, turns out, which is great. I mean, content. We like it. And one of the questions that came up in one of our first episodes, I think it was lesson 3 about dissolving.
Mm-hmm.
And we talked super briefly about it became like a side comment that could have been its own rabbit trail, and I'm pretty sure we practiced like amazing self-control and stayed on topic, and it was so great. But you mentioned something about sugar melting ice. Do you remember this?
I do. Yes.
Do you think it's true?
I do think it's true because I'm the one who said it.
Okay, great. So you stand behind your word. So I'm just wondering how.
How what?
How does sugar melt ice?
Oh, okay. So that's our question. How does sugar melt ice? All right. Well, let's start with our pre-assessment as usual. Maybe let's start even with just melting because you've learned some stuff about melting so far. What do you remember about melting?
Melting is when a substance turns from a solid into a liquid.
Okay.
And with water, that happens when it's above 32 degrees Fahrenheit.
Okay.
I could say that there are different variables that could change how quickly something melts.
Okay.
Yeah, like the size of the ice cube, for example, or how cold it was and how warm it is now, and am I pouring boiling water on it?
Okay.
Yeah, those are things I know about melting.
Those are good things to start with. Now let's add sugar into the mix. What do you think sugar might be doing to the ice that gets it to melt?
So when I make caramel, I put sugar in a pot, and it is only sugar that goes in the pot. And eventually it is boiling. And if I poured that on an ice cube, I'm pretty sure the ice cube would melt.
You're correct. If you poured boiling sugar on an ice cube, I think you're right. I think it would probably melt.
But I'm guessing that's not actually what we're talking about today because that feels a little obvious. I'm guessing we're talking about solid room temperature sugar.
Yes, we are.
And without actually even knowing that that was a thing that was true until we recorded that episode, my guess is going to be that it's something about molecules.
Oh, something about molecules.
Because when we talked about dissolving, we talked about how the sugar molecules are still sugar molecules. It's just that the water gets between them. So much so that it's not like the grainy sugar anymore, but it's sugar kind of molecules mixed in with the water molecules. And that happened at different rates depending on the temperature of the water. But what's confusing to me is that frozen water, the molecules are hardly moving at all.
Okay.
And I'm guessing that with solid sugar, the molecules are hardly moving at all. If I can say that the same thing is true with other solid substances that are not water. So I don't know why, other than if it's like a similar thing of it, like the water dissolving the sugar molecules, is the sugar molecules causing, but I don't know why. Like if they're both just, if those molecules are just minding their own business and just sitting still and just like hardly bouncing around or anything, then I don't know why they would affect each other. I feel like they would just sit on top of the other one. But I feel like it might have to do with that.
Okay. And one final sort of follow-up question related to this.
Okay.
I'm guessing you have heard before that if you put salt on ice, it'll melt.
See, I think I heard that the same time I heard from you that sugar does it. Other than maybe I've heard it before and it sounded like an old wives' tale.
Okay.
Because
So
you hear
that,
these things of like, you rub lemon juice on your mosquito bite and it like helps it itch less. You hear all these things out in the world.
right.
And I might have heard that and been like, okay, sure. But
Gotcha.
like, I didn't actually hear that that was a fact until you told me recently.
Okay. So that was not something that was familiar to you previously.
No.
Okay. Are you ready for some explanation?
Yes, please explain yourself.
What, myself? I have to explain myself?
Yeah,
That's
I've been
going to take a
waiting
lot more
for
time.
like 15 weeks for this explanation. So make it good.
Okay. All righty. Well, let's just start with where you started, which is you gave a great definition of what melting is, something going from a solid to a liquid.
Great.
And you said that water typically melts at 32 degrees Fahrenheit.
Yes.
Which is true under ideal conditions. But you can actually change those conditions. And when you do that, you can actually change the temperature at which water melts.
Ryan.
Yes.
We have been in this hot and cold unit for, what are we, like 7 weeks or so? It's
something like that.
It's been a minute. And you are just now telling me in our final week of this unit that I could just go changing the temperature that water melts at.
Well, that's not exactly what I said. I didn't say you can just go change the temperature that water melts at. But yes. And when we arranged the order of these units, I intentionally put this one last.
Oh my goodness. This is more interesting. I mean, okay, your lessons are interesting. But like this is crazy. I didn't know I could do magic.
You can.
Cool.
Yeah.
I'm so excited.
You're a wizard, Cheryl.
Yes.
But in order for you to understand it, you needed all the other stuff that we've already talked about to be able to build on. If we had started with this, you would have had a million other questions that I would have said, ask that later, ask that later, ask that later. And then you wouldn't have been very satisfied.
So you were lesson planning.
I was definitely a lesson planning.
Good job.
That's true. Thank you. Thank
Yay.
you. One of the ways that you can change the temperature at which something melts at is by dissolving something into it.
Ooh.
And that's what this is doing. It's actually very similar. Remember when we talked about boiling?
Yes.
And we talked about how you can add salt to water and you can change the temperature at which it boils?
We touched on that.
Yes. Very briefly. And I said, yes, technically it makes a difference, but I did the calculation in college and it doesn't make enough of a difference that you would notice.
Yes. Yeah.
That's actually the exact same thing as this, just going in the opposite direction.
Oh.
You want to learn a really fancy, fun science term?
Always.
Yes. What we are talking about today are called colligative properties.
Colligative.
Isn't that fun to say?
Colligative. Sure.
I'm a science teacher, not a speller.
Oh, I was trying to guess.
I think it's something like that. Yes.
Okay.
So there's a whole set of colligative properties. Basically, the simple version is those are things where it doesn't actually matter what the substance is. So it doesn't have to be sugar. It could be sugar or salt or another liquid or some other solid or whatever, but it's going to have the same effect regardless of what the thing is. That's obviously an oversimplification, but close enough for what we're doing right now.
Cool.
So what you do is if you dissolve something into a liquid like water, you can actually alter the temperature at which it goes through a phase change. In this case, we're talking about the temperature at which it melts and freezes.
Cool.
So that's big picture where we're at.
Okay.
Okay. You're still like, I'm not tracking.
I'm interested to see where you're going with this.
Okay. The second thing that you talked about was, as usual, already thinking along the right lines, and you were applying some of those ideas that you've already learned through this unit. You talked about that maybe the water is getting between the sugar molecules.
Yes. Uh-huh.
That's exactly what's happening.
Really?
Yes.
But why would it do that when they're frozen?
Which was the next question or thing that you said, which is, but they're moving, but they're not moving very much.
Yeah.
Right? You remember that the molecules are moving, but they're kind of more moving in place.
Mm-hmm.
They're moving enough to get in between each other, at least right there on the surface.
Wow.
And they're moving enough, and it's kind of this runaway is probably a little over dramatic, but as it starts to happen, as just a little bit on the surface between where you have, let's say, the water and then where you have the sugar, where they're in contact, that's where it's going to start. They're going to start working their way into each other. But as you do that, now what you say is you are depressing or lowering the freezing temperature, which means it's going to become a liquid. And as there's more liquid, it's easier for the sugar to dissolve.
So then it can happen faster and faster.
It can happen faster. Now, it's not all of a sudden that it's going to, oh, look, boom, and then it just all turns into a liquid right away. It's not that. When I say run away, that's why I was like, yeah, it's not quite away. But it definitely is something where the more it happens, the more it's able to happen to a point.
That's so cool. But so I understand how it happens, but then why does it help it melt at a different temperature?
Okay. And in order to help you picture this, I think I'm going to have to do some drawing for you.
Oh, good. Art class. I'm excited.
Art class, because I'm clearly an art teacher. That's the way we've definitely said this the whole time.
Mm-hmm. Yes. And this is a good moment to remind our listeners who are listening to this as an audio podcast that we are also on YouTube, and you can watch our silly little faces as I learn science. And also you can watch Ryan screen share and show us his art skills.
My amazing art skills. Yes. All right. Can you see my screen? Okay, Cheryl.
Yeah, you already titled it too. I'm very proud of you. Sugar and Ice.
Thank you. Yes, I planned ahead or something.
Wow. So amazing.
I know. So amazing. Well, let's just start where I'm just going to draw a container, which literally looks like a boxy U shape because I'm not that creative. So got a container, and let's go ahead and put some water molecules in there. And I'm not going to do anything that's all that fancy. I'm literally just going to do a bunch of dots.
Where's the popcorn on it, though?
What do you mean the popcorn?
Don't they have the little like red balls?
Oh, yes. What you're remembering is that there's kind of a 3-part molecule. Remember, water is
Mickey Mouse.
H2O. Yep, looks like Mickey Mouse because you've got the oxygen and you've got 2 hydrogens. So that's the O, and those 2 are the H's that kind of are off sort of at an angle. I typically draw it what's more like an upside down Mickey Mouse, but you can definitely draw it where you've got the 2 hydrogens kind of up above like that. And actually, now that I think about it, I still have a few of the little models that you loved so much here to kind of see what they look like. There technically isn't an up or a down, but yes. What I'm doing for this is I'm oversimplifying and just drawing the entire thing as just a dot. So each of these dots that I'm drawing here just represents that H2O molecule.
Okay.
Does that make sense?
Yes. And it looks similar to that melting little like example that you showed me where it was like some website and they were like the little molecules were jiggling.
Yes. Yes. It looks very similar to that. So we've got that. Now let's go ahead and we're going to add the sugar, and I'm going to make the sugar green. I don't know why, but I am. And the sugar molecules are way bigger.
Whoa, really?
Than the water molecules, because sugar's chemical formula is C6H12O6.
Oh, wow.
So there's a whole lot more atoms in the first place that make up a sugar molecule. So they're just significantly larger. Now, what I'm drawing is obviously not to scale, but I'm drawing, and again, I'm drawing them just more or less as kind of circles, even though it's not really their overall shape. It's just a little bit easier to give us an idea that there's something there. And so you've got those two sort of right next to each other. As they're in contact with each other, they are still jiggling and moving, and they're banging into each other.
Wow.
Does that sound familiar?
Yes, it does.
So even though they're in place, if they're in contact with each other, they're still banging into each other, which means you can kind of bang some of those water molecules so that they kind of bounce off. If they get just a little bit more energy, they might have just enough energy to start going in between each of those sugar molecules. And then you can break a sugar molecule free, and then it starts to move towards into that frozen water molecule, and it kind of feeds on itself as they're still moving. And all of a sudden you end up with these water molecules that are in between the sugar molecules, which dissolves the sugar, but also separates those water molecules from each other and allows them to be a liquid.
Faster than it would on its own.
Just sitting there. Yep. Because what you're doing is you're in a sense pulling them apart from each other more quickly, because you've got that jostling and transfer of energy and all that good stuff.
That's so cool. So is that what salt does?
What do you mean?
Does salt do the exact same thing?
Yes. Yes, it does. In fact, you might be familiar with, because you said you hadn't really heard of salt dissolving water at all, or dissolving or melting ice, I guess.
Yes. Yeah.
Right. Have you ever made ice cream at home, homemade ice cream?
No, only with you, with the liquid nitrogen.
With the liquid nitrogen.
The classic way.
The classic way.
Grandma and grandpa used to do
with the liquid nitrogen. Growing up, we definitely, my dad especially had an ice cream maker and made that at home. And part of what you do is you dump rock salt on ice that's around the outside of it.
Oh, I've heard of that.
To cool. As a matter of fact, I've made ice cream at school with students before that way. Maybe we should do that sometime, is make our own ice cream.
For a lab.
For a lab. There you go. We can make ice cream.
Delicious lab.
Exactly. So that works. It does that for that. I don't know if you ever heard of salting roads.
Oh, yeah. Oh, yeah.
Yeah.
Oh, I knew about that then.
Yeah. Salting roads. Now, technically, now they use salts in a chemistry sense, which is not necessarily table salt. There's lots of different substances that chemists refer to as salts. And what we typically use on roads now is not sodium chloride, which is regular table salt, but I think they might use potassium chloride and some other things that are similar and have very similar properties, but behave a little bit differently. They don't corrode cars as easily. They're a little bit more environmentally friendly, some of those sorts of things, but have the same general effect.
Interesting. Okay.
This is also the exact same way antifreeze works. If you're familiar with antifreeze.
Yes.
Like in a car or something.
Mm-hmm.
Yeah. Antifreeze is a liquid that doesn't freeze at water's freezing temperature.
Yeah.
but it's mostly water. It just has other things dissolved in it to allow it to go a lot colder
Interesting.
before it freezes, to let everything stay in your car so your car doesn't freeze, because it doesn't run as well when it's frozen.
Yep, that would make sense. Yeah.
Yeah.
Wow, that's so cool.
Yeah. So, I mean, that's basically it, I think.
Cool.
Does
I love
does
it.
it feel like that explains it enough for you?
Yeah, absolutely.
Great. And with that, it's time for your favorite part of the lesson, Cheryl.
A part of the lesson where I take a nap?
The part where you take a quiz.
Ooh, I was worried you were going to say that.
Yep. You knew I was going to say that.
Yes, that's why I was worried.
Because you knew it would happen. Question number 1. Does water always freeze at the same temperature?
No,
How do you know?
because if it was mixed with other things, then it would freeze possibly at a lower temperature because of the other things, whatever those are, molecules in between the water molecules, making them not frozen yet.
Wonderful.
That was scary at first.
I could tell. I could tell you were a little bit, but you got it. You didn't give up, and you got it. Nice job. Question 2. Compare the size of water molecules with the size of sugar molecules.
Ryan, that's apples and oranges. No, not really. Those are very similar sizes. That's watermelons and oranges.
Okay, which is which?
The sugar molecule is the watermelon, and the water molecule is the orange.
Great. Wonderful. Question 3. What happens to the molecules when ice and sugar touch? And then sort of the follow-up question is why?
The molecules stay the same. They are still water and sugar molecules.
Okay.
They just start intermingling with each
Ooh.
other. Like middle schoolers at a dance.
I feel like middle schoolers at a dance don't intermingle very
Well,
much.
awkwardly moving around and accidentally, weirdly bumping into each other.
Okay, sure. I'll accept that. Yeah. Good description.
It's slow. It's over time. It's weird to watch. It doesn't really look like dancing.
Okay. I will forever have that image in my head.
Yes.
And the last question is an application question, your
Oh,
favorite
boy.
kind.
Okay. Okay.
Would putting baking soda on ice cause it to melt? Why or why not?
I would guess yes. And I would guess we could go down a list and list all sorts of things that come in small grains
Mm-hmm.
that are in a solid form that would help ice melt. Like, I don't think if you put a textbook on top of an ice cube, it would do much.
Okay.
I don't know. Maybe being surrounded by not air instead of, like, who knows? If it's a better conductor, it actually might do something. But I would think that baking soda is also very small grains, much smaller than salt or sugar
Okay.
in like the size of it. So it feels like, yeah, it would also do a very similar thing to salt and
Yes.
sugar.
And it would. It would be
Cool.
very similar. Do you remember the fancy science word I taught you that describes that?
Caligulate.
Very close.
That sounds too much like Caligula. Isn't that like an awful bunny in some book or something?
I don't know.
Oh no. I bet I got it wrong, but like slightly.
Yeah. Colligative.
Colligative. Okay.
Yes. They're colligative properties because yeah, you're right. It doesn't matter what the actual substance is. It's going to have a very similar effect.
Polenta.
Uh-huh.
Small grains of rice.
Really small grains of rice.
Brown sugar.
Oh, brown
baking
sugar.
powder.
Baking powder. There you go. You got your
laundry
list.
detergent.
Mm-hmm. all sorts of things. So excited. Well, guess what, Cheryl?
Now it's time to go home.
Well, we just finished a unit. We just finished our hot and cold unit.
Yes, we did.
Yeah.
So fun.
You know what usually comes at the end of a unit?
Spring break.
But right before that,
Movies in class.
a unit test.
No,
You want to take a test, right?
I just took one, Ryan.
No, you just did a quiz.
Oh, it's one of those things we're going to get all technical about. Well, technically, you've never taken a test on this podcast before.
Well, you haven't. You've only done quizzes.
I mean, I don't want to take a test, but if you would like me to, I will suck it up.
I actually don't think you need to take a unit test. What I'd rather do is do a unit reflection, if that's okay.
Oh, that's sweet. I like that.
You like that idea better than the test?
Yes, I do. Yeah.
So what I'd love for you to do is kind of think through all the stuff we had on this unit and what did you find the most interesting, the most challenging, the thing that you think might stick with you the most. And it doesn't have to be the most, but a top thing in any of those categories.
Yeah. I think what was interesting was a lot of the things with hot and cold I probably already knew were true or like had seen. It's very like everyday items that we were talking about, minus the liquid nitrogen. But so it was interesting learning the why behind some of those things that I encounter in my kitchen, you know.
Yeah.
And so I think that was really fun. What was the next question though?
So I said the things that you found interesting, the things that you found the most challenging.
Okay, challenging. Gosh, it is so hard with science how you can explain it and I can get it. And then you ask me a question and I have to say it back to you. And I'm like, you just told me this. And it's like, it is. And I know that's a like level of learning is being able to explain it is very like a different level. And so, yeah, I think that was challenging. And stuff about molecules are difficult. So, yeah.
Okay. Yeah. What you're describing of that sense of, yeah, oh, it totally makes sense. And then you have to go to answer a question or explain it. And all of a sudden it's a lot harder. That's not something that's actually unique to science. You might experience it more related to science, but that's just learning.
That's true. Yeah.
That's the process of learning. And we don't like it. It doesn't always feel great. But that's one of the things that sometimes contributes to people doing worse on a quiz or a test than they expected, because it makes sense in your head. And until you have to put it together yourself, your brain hasn't done all of the work to make all of those connections yet. And so by having to answer those questions or repeat it or explain it yourself, you have to work through some of those things that somebody else had already worked through for you, if that makes sense.
Well, something I think about a lot is the difference between what is it, recall memory versus recognition memory, I think are the two terms. I learned about it in psychology. And like it's like if you get a multiple choice, then you're like, oh yeah, that word, it's that one, versus a fill in the blank is you have to come up with it yourself. And it feels like a similar thing of like, if you asked me a basic question or said, is this right or wrong? I might be able to answer it versus like explain it.
Yes.
It's much more difficult.
Yes. And that is true. And the last thing was, what concepts do you think you might remember or stick with you or?
I mean, I think like we kept coming back to like, what is a solid or like what, like these different states. And I think that that will definitely stay with me. And then I think even thinking through like, and this wasn't even part of the hot and cold unit, but on our dissolving episode, the fact that like when sugar dissolves in water, it's still sugar, like thinking about things like that of like, it's not gone. It's just like microscopic or, you know, I don't know. That was really interesting too. Just starting to put these things together, I think, is starting to stick with me of some of these principles.
And I would agree with both of those. I think I've seen you come back and reference those things multiple times. That just
Yay.
reinforces that, yeah, those things are sticking with you and they are kind of things you continue to think about, not just when we're recording for, our podcast.
Yeah. And that's cool.
Yeah. Awesome. Great reflection. A+.
Oh, wow.
Well, that is all the time that we have for our lesson and for our unit. So why don't you start packing up your stuff and getting ready for my closing remarks? You can follow us on Instagram and Facebook at I Slept Through Science or on Twitter at Slept Science.
If you have dumb science questions like I do, please send them to us. You can email us at isleptthroughscience@gmail.com, or you can even send us a voice memo and we'll play it on the podcast.
Please rate and review our podcast to tell other people what you think about it, subscribe to make sure you don't miss an episode, and share about our podcast on social media.
Thank you to Beth Reed Miller for the artwork. You can check out more of Beth's artwork at Beth Is Something. Okay, great. Thanks. Bye.
The bell doesn't dismiss you. I dismiss you.